with me as I walk you through questions from the Year 9 curriculum in preparation for the end of year exam. Before we begin, let me say that this video is suitable for all Year 9s, whether you do the foundation or the higher paper. It is very important that you watch all the questions, as I'll be covering different questions from the different strands. Also, do not rush. Take all the time you need. If you have to rewind, pause the video and go through as many times as it takes to ensure that you leave this revision confident to approach that exam. Also, in the description, there'll be a timestamp that tells you which strand is being covered for each question. So, let's begin our revision. So our first question is on frequency trees. Let's have a read of this question. Complete the frequency tree which represents 200 members of a gym and use of the gym. So I'm just going to underline the key thing here. First of all, I know that there are 200 members of this gym. So we're given the diagram here. We can see that the total is put in for us, which is 200. We've got male and we've got female. Also, we have those people who attend twice or more. Then we've got males who attend less than twice a week, females who attend twice or more, and less than twice a week. We're asked here to calculate the percentage of people attending twice or more a week. Then the second question, we're asked to calculate the percentage of females who attend less than twice a week. Clearly, the first thing we're going to need to do is to complete the frequency tree. So we go ahead and we can see here that the first thing we need to do is to calculate the missing number for the females. So we know the total is 200. So I'm just going to write here female is equal to the total take away male, which is 200, take away 124. We just put that in our calculator, and then if it's a non-calculator paper, however, you just simply need to use the column method to do that. So 200 take away 24, that gives us 76. We go ahead and we put that on our diagram. So we've got 76 females. Now we also need to complete the section for male who attend twice or more. We know the total for male is 124. So we just need to go ahead and do 124 take away 68. Put that in our calculator. 124 take away 68, and that gets us 56. So we put that on the diagram. Also need to find the females who attend twice or more. So we know the total for female is 76. So 76 take away 26, and that is easy to do in our heads, that equal to 50. So we put that on our diagram. Now that we've completed the diagram, we're now able to answer the questions. So the first one asks us to calculate the percentage, so we underline that, of people attending twice or more a week. So that's going to include, so we look on our diagram, we look for twice or more. I'm just going to put a star here, so male 56, and also females who attend more than twice a week, let's put a star there as well. So now we need to get the total of male and female who attend twice per week. So we need to do 56 add 50. Calculator paper again, you can put that in your calculator, and that gets us to 106. Now we have to write that as a total a fraction of the total amount of people that goes to the gym. So it's 200 people, so therefore it's 106 out of 200. Now we want this to be a percentage, and we know the denominator should be 100 if we have a percentage. So therefore I can just divide by 2 here, numerator and denominator, and then we would now have our answer as a percentage. So 10 divided by 2, that's 5, and 6 divided by 2, that's 3. And half of 200 is 100. Now that we have a denominator of 100, then we can simply just write 53%. And there we've got our answer. So we now go to the second part of the question. So the second part of the question asks us to calculate the percentage of females who attend less than twice a week. So we look back on our diagram for female, less than twice a week. I'm just going to put a tick here. So that is 26. And that should be out of the total females. So that's out of 76. And then we want it as a percentage as well. So we simply multiply this by 100. So I'm just going to put that in my calculator. So 26 divided by 76. And then I need to multiply that by 100. I'm just going to put my answer to 1 decimal place. So that is 34.2%. And there we have it. We've answered our first question on frequency trees. So we're going to go on to our second question. So we've got another question here on frequency trees. We're told 80 teachers were asked if they prefer tea or coffee. So I'm just going to underline that 80. So we know the sum of the entire diagram is 80. We can just go ahead and put that in straight away. 3/8 of the teachers were male. So let's go ahead. We know we've got males. I'm just going to label M for the males. Therefore, the rest has to be female. So we're just going to label this one F. And we know that is 3/8 of those teachers were male. So it's 3/8 of 80. And we know in mathematics, the word of indicates multiplication. So I'm just going to go ahead and find out how many of those teachers are males. So we're going to do 3/8 and then multiplied by 80. So it's the same as doing 80 divided by 8 and then multiplying by 3. I'm just going to simplify. 8 into itself goes once, and 8 into 80 goes 10 times. So therefore, the male teachers are 30 altogether. So we're just going to go ahead and put that on our diagram. Now we can see, we know the total is 80, and if we know male is 30, we can also go ahead and fill in the female. So let's go. Females would be equal to 80 take away 30, and that gets us to 50. So we're just going to write that in on the diagram. So you can see here we are closing in our gaps. Now we go to another bit of the information here. We're told that double the amount of male teachers prefer tea than coffee. So tea to coffee then for the males is a double the amount. So it's 1 to 2. So that means if there are 30 males, if we add the ratio parts together, it's 3 parts. So if I divide 30 by 3, I get 10. That means on the first one, it's going to be 10. And then I've got 20. So this one is our tea, and this one is our coffee. So I need to swap these around. So this was our coffee, and this one was our tea, because double the amount of tea than coffee. So we filled that branch in. Now we tick this off because we're done. Now the female teachers preferred tea and coffee in the ratio 2 to 3. So we're going to work that out. We know there are 50 female teachers altogether. So we're going to write, make sure you put them in the correct order. So it's tea to coffee. So I'm just going to write females here. and they prefer tea to coffee in the ratio 2 to 3. And we know all of the females are 50 altogether. So we need to find out how much will be tea for the females and how much will be coffee. So let's just write that there on our diagram and then work it out. So adding these two ratio parts together, we get 5. So therefore we need to do 50 divided by 5, and that gets us to 10. So we can find out tea by doing 2 times by 10, which is 20, and 3 times by 10, which is 30. So that will be in the ratio 20 to 30. So tea was 20, so we put that in, and coffee was 30. Good, so we finish our diagram. Now we've got one question to answer here. So it says, you select a teacher at random. If a teacher is selected at random, when the word random is used, it means out of the entire population. So we know there were 80 altogether. So if a teacher, I'm just going to underline the word random, which is what I also want you to do when you are doing your paper. Give yourself that focus. So what is the likelihood that the teacher is a female who prefers drinking tea? So we go to the branch, we can see here females who love tea is 20. Just put a little tick there. So to answer the question, it's going to be 20 out of the total, which is 80. And what is the probability that they prefer drinking tea? I can just simplify this. What I can do, if I don't know the highest common factor, I can start with a small value and then keep reducing until I cannot simplify any further. So I can see here I could divide by 20. So dividing by 20, I get 1 for my numerator and 4 for my denominator. So the answer then is 1/4. And make sure you check again that you have simplified correctly. So I divided by 20. 20 into itself goes once, and into 80 goes 4. So now we have completed 2 questions on the frequency tree. So let's go to our next question. Okay, so this one is now on the probability tree. So we're told that a Asib is going to play a tennis match and a squash match. The probability he wins the tennis match is 7/10. The probability he wins the squash match is 3/5. Complete the probability tree diagram. Now we know that probability adds up to 1. Therefore, we want the fraction here for the losses should add to 1 when we do 7/10 plus that fraction. So we know the denominator here is also going to be 10. So we're just going to put 10 here, and then we just need to get up to 10. So what plus 7 gets us to 10, and that's 3. So we know that the losses had to be 3/10. We go on to our second branch. Now we're told that squash is 3/5. So again, we need to add up to 1. We know the denominator is also going to be the same. And then we ask what plus 3 gets us to 5/5. So that's 2. And we know the other branch is always replicated. So on the first one, it will be 3/5. Followed by 2/5. So now that we've completed the tree, we can now go ahead and answer our question. So it says, calculate the probability that Hasib will lose both matches. So we need lose on the first one, on the first game, which is tennis, and also is going to lose on the second one, which is squash. So we're going to identify the probability of loss on the first, which is 3/10. So we're going to write probability of a loss, and the loss is equal to, the first loss is 3/10. We go to the next branch and we look for his loss as well, which is here, and that is 2/5. So we need to multiply them together. So 3/10 multiplied by 2/5, and 3 times 2 gives us 6. And 10 times 5 gives us 50. So we've got 6 50ths, which we could also have simplified by dividing by 2. So half of 6 is 3 and half of 50 is 25. So our final answer then is 3/25. Well done. So we're now going to do another question, similar style. However, this time we are representing our values on our tree in decimals instead, but the same principle apply because we know that probability always adds to 1. So let's go. So we're told here that Joe walks to school every day. The probability Joe is late on a Monday is 0.4. The probability that Joe is late on a Tuesday, just give me 1 second, on a Tuesday is 0.2. Complete the probability tree diagram. So again, similarly, we know that probability adds to 1, and on our first branch we've got 0.4. So we know that the probability of not late has to be 0.6. We could say 6 plus 4 is 10, therefore 0.6 plus 0.4 is 1. And on the other day, on Tuesday, he's late 0.2 times. So that means not late will be 0.8, and also replicated on the second branch. Now we've got everything we need here. We can now answer the question. So it asks us here to work out the probability that Joe is late on only one of the days. So that means he could be late on Monday, but he's got to be on time on Tuesday. Or if he is on time on Monday, he would be late on Tuesday. So let's go ahead and write that down. We need probability of late and not late, and also the probability of not late followed by late, and then we will add them together. So let's go. On the first one, late is 0.4, so that will be 0.4 times not late on the second one, which is 0.8. Just going to write them down and then we put the answers. Now, not late on the first one is 0.6, and late on the second one is 0.2. So all we need to do is to just multiply these and then we add their answers. So we've got 0.4, we can just put that in your calculator, times 0.8, which is 0.32. And then we need to do 0.6 times 0.2, which is 0.12. Awesome. So now we've got them nicely lined up here, so we could just put a little plus here and just add them straight away. So 2 plus 2, that's 4. 3 plus 1, that's 4. So the answer here is 0.44. And then we simply have completed 2 questions on the probability tree. Brilliant. Awesome. So we're going to go on now to our next question. Another question on probability. So we're told here that a coin lands on tails 200 times. So let's underline that. 200 times, so that is our number of trials. We're told that the relative frequency of tails is 0.4. Work out the number of times the coin has been thrown for 2 marks. Okay, so we know that 40% is the same as 0.4. So 40% represents 200. Now, from 40%, we could go ahead and find 10%, a very good reference point all the time. So 10%. Let's work out how do we get 10. So if I know I'm going from 40 to 10, I would have to divide by 4. So if I divide this side by 4, I need to also divide my right hand side by 4 as well. So let's start by doing 20 divided by 4, which is 5. And then 0 divided by 4 is 0. So 10% then is 50. We're asked to find the total number of times the coin was thrown. So that means I need 100%. So we go ahead and we're going to work out what is 100%. Question here becomes, how do I get from 10 to 100? So if I multiply 10 times 10, I get to 100. Means then I also need to multiply my right hand side by 10. So 50 times 10 gives me 500. So therefore it was 500 times that this coin was thrown. So you can see the clear logical steps there. Always try to find a basic rate that you can work with, in this case a basic percentage. So we know we could go from 40 to 10 and then we could make a connection with 10 and the total, which is 100%. Now in this question we're told that the arrow on this spinner is equally likely to land on each section. We observe our spinner, we can see we've got 1, 2, 3, 3, 4, 4. Equally likely. So there are 6 parts on this spinner. We're told that the arrow is spun 72 times. So we underline that. We're asked now to say, how many times do you expect the arrow to land on a 4? Now remember, expectation is equal to our relative frequency multiplied by the number of trials. So first thing we need to do here is to find out what is the relative frequency or the probability of getting a 4. We can see here there are 2 4s on the spinner and the spinner has 6 sections. So the relative frequency will be 2 6. Now we can see the question told us this was spun 72 times. Therefore, the number of trials is 72. So all I need to do is to multiply my relative frequency times my number of trials. Now, if this is a non-calculator paper, then your knowledge of your timetable would have helped you severely here. So let's go. I need to divide 72 by 6 and then multiply the answer by 2. So 72, let's go, 6 into itself goes 1 and 12 times into 72. So 6 times 12 gives us 72. So once I multiply 2 times by 12, I will get my answer. And my answer is 24. So I expect my spinner to land on a 4 24 times. Simple. So that was 2 marks. On we go. Now here we're told that the result of a game is win, lose or draw. After 80 games, number of trials, 80 games, the relative frequency of the result win was 0.4. A good practice here is to take your numbers out of the words. So win is 0.4. Then the relative frequency of the result lose is 0.25. So let's put that also here, 0.25. We're asked now to say how many of the games had a result of draw. So we underline that, give ourselves that focus. So we know that probability always adds to, I hope you said 1. So what we need to do first of all is to find the relative frequency for the number of draws. And we did the question before where we find our expectation by our relative frequency multiplied by the number of trials, which in this case is 80 games. So let's go. We're going to add 0.4 plus 0.25, and then we're going to subtract that result from 1. So we can just go here and do 1 take away and put in brackets what we're going to add. Then just put that in our calculator. So we've got 0.4 plus 0.25, and that part on its own gets us to 0.65. Now subtracting this from 1, so we can think about it as 100 as well. 100 take away 65 is 35. So therefore, if we're doing a decimal, we're clearly going to get 0.35. And we just do a simple check and make sure that gives us 1. And now we've got our relative frequency for draws. So we're going to just write here, draw then will be equal to, or we could just say the number of draws, since that's what we were asked to find. So the number of draws will be equal to our relative frequency, which is 0.35, multiplied by the number of trials, which is 80. We'll put that back in our calculator. So 80 times by 0.35, and that gets us to 28. We put that on our answer line, a beautiful 3 marker there. So once you apply the concept, we knew that we had win, we knew we had loss, so that means we needed the relative frequency for draw, and all we had to do was to add them all together, and once we add them together, we subtract from the total, which is 1. And then relative frequency multiplied by number of trials is equal to expectation. Beautiful. Here is a prism drawn on an isometric grid. Work out the volume of the prism. So I'm just going to go ahead and underline the word here, volume. Now, the fact that this is a prism means that it has a uniformed cross section. And by that I mean, if I should slice this prism to give everyone in my class a piece of it, let's just think about it as a block of cheese. I would have to slice it from the front, which is on this side of the L shape, all the way to the back in order to get that same shape all the way throughout its length. So that's how I identify. Now you can see if I should cut it from the rectangular part, the shape is going to change by the time I get to the front of that. So that means the only way I could slice this is along the L shape, which is actually the cross section. So what we're going to do now, having said that, we need to write down the formula for the volume of a prism, and that goes through for any prism at all. So the volume of a prism, is equal to the area of the cross section, and then I multiply that by the length, and the length we get from the front of the prism all the way to the back. So in this particular question, the length is 6 centimeters. Now we need to go ahead and find the area. Now we can see that the area is a compound shape, which means that we will have to divide this shape in 2 parts. So I'm just going to go ahead and make a small sketch here, and then I will identify the section that is best to cut it in. Now sometimes people choose different ways they want to cut their shapes, but always try to choose the one that's very much easier in terms of the measurement to navigate. So I think here the best way to do this is to just cut it across. So I'm going to call the top of it shape A and the bottom of it shape B. I'm just going to do that on my sketch as well, A and B. Now on this grid, we need to count the squares in order for us to write down the length and the width of the rectangles. So I'm just going to go ahead. If I start here, 1, 2 along, and from this side, 1, 2, 3 along. So the area of A, so area A is equal to 2 times by 3, which gives me 6 centimeters squared. Or we could just say 6 because we're not sure if this is a centimeter grid at all. So we just keep it as 6. So B, we do the same. If we go along, 1 from here, 1, 2, and across it's 1, 2, 3, 4. So this one is a 2 by 4. 2 times 4 gets us 8. Now, we have to remember to add these together because we need the area of the cross section, which is shape A, added to shape B. So we go ahead, the total here is equal to 6 add 8, which gives us 14. Now, we found that cross section, we need now to multiply that by the length. So the volume then is equal to 14 multiplied by 6. Now we can put that in our calculator. If it's a non-calculator paper, you go ahead and do 4 times by 6, which is 24. And then we'll bring a small 2 over. 6 times 1 is 6 plus 2 is 8. So the volume is 84. We can just write 84. Let's just say centimeters cubed. So this part was in centimeters. I missed that there. So yes, it's all centimeters. And there we found the volume. Now, very importantly here, it doesn't matter what is the shape. Let's say the cross section was a triangle. You would then find the area of the triangle and then multiply it by the length. If the cross section is a trapezium, you go ahead and find the area of the trapezium and then you multiply that area by the length. So remember, volume of prism, area of cross section multiplied by length. So we go ahead to our next question. Now, the front elevation, side elevation, and plan of a solid are all the same as shown. So we can see here, this shape is a square. It asks us here to write down the name of the solid. So we've got to think, if the front elevation, which is what we look on to see, the side of it, and the plan view is what we look down on and see, if all of this are the same, the only shape that this could be that has all sides being the same has to be a cube. So we go ahead and we write that down. So cube. Okay. Part B says the front elevation, side elevation, and a plan of a solid are all the same as shown. Write down the name of the solid. So we go ahead and think. The front elevation, I'm looking on and I'm seeing this circle. The side elevation, I'm looking from the side and I'm still seeing a circle. The plan view, I'm looking down on the shape and I'm still seeing a circle. Then what shape could it possibly be? Now, some people will be tempted to say cylinder, but remember, we are looking at it all the way around, so could not be a cylinder. Lots of students get these questions wrong because once they see a circle, they're thinking cylinder. But remember, the criteria is from the top, from the side, from the front has to look circular. The only possibility here is a sphere. So S-P-H-E-R-E, sphere. So that's our answer. So we move along to our next question, another one where we have to now draw the views from a given solid. This shape is made from 5 cubes. We're asked to draw what the shape looks like when we see it from A, from B, and from C. So what you've got to do here is to imagine yourself standing in these positions, and you're going to draw exactly what you see when you look from that position that you're standing. So we're going to go ahead and we're going to look at A. So imagine yourself standing here at A. If you look dead on, what exactly is the shape that you see? I can see here, if I'm standing here, I'm going to see this cube. So I'm just going to label all the cubes I would be able to see. So I'll see cube 1, cube 2, cube 3, and cube 4. So that would be like an L shape, but standing upside down. I go to my grid and I draw exactly what I see. So I need to have 2 across. And for this one, it doesn't really matter where on the grid you draw this, once it is the exact measurement across. So across we need 2, 1, 2 squares, and down we need 3. So we go 1, 2, 3, and then we need to join them all together. So therefore, I now have drawn what I see from shape A. For shape B, I'm going to go to stand along the side. So I'm going to label. I'm just going to put some ticks here this time, not to confuse the numbers. So I'll see this square, I'll see this one, I'll see this one, and I'll also see that one. I can see here it's also an L shape. So one across, and I need to have 1, 2, 3 down. So 1, 2, 3 down. So I'll complete that bit, and I also need to have this tiny one across as well, so I complete my L shape. So it's pretty much the same I've done for shape A, only that the orientation has now changed. Now I'm asked to draw the view from C. So from C is my plan view because I'm looking down on the shape. I will just be able to see, I'll put stars here now, this one. I'll also see this one, but also the one along the side. So therefore, I will have 3 cubes altogether. And again, the orientation doesn't really matter. 2 on top and 1 on the bottom bit as well. So orientation wouldn't matter here. If you didn't draw yours, but you have the same layout, you would still have scored that marks, and that's 3 marks altogether. Now, before we get started on the next question, have you shared? Now remember, our end of year is so close, and we want to make sure everyone gets the chance to benefit from these questions. So go ahead if you haven't done so yet and share with a friend. Now, having said that, let's get into our next question. Now, we are asked here to identify the name of this shape. Part B, what is the sum of the interior angles? And part C, how do you know this shape is not a regular polygon? So we're going to take a question at a time. We're asked to identify, first of all, the name of the shape. So best practice here is to number the sides as you count them, so you know what shape it is. So I'm going to start here. 1, 2, 3, 4, 5, 6. So it is a 6-sided shape, which makes it a hexagon. Clearly, all the sides and angles are not equal. Therefore, specifically, it is an irregular hexagon. So the answer is irregular hexagon. Okay. Now, the next question says, what is the sum of the interior angles? So we need to remember our formula. So the formula for the sum of interior angles is 180 degrees n minus 2, where n is the number of sides. And the reason why we are multiplying by 180 is because the angles in a triangle add to 180 degrees. So when we do n take away 2, we are finding how many triangles this particular shape has. So 6 sides, so that's going to be 180. 6 take away 2, which is 4. So it's 180 multiplied by 4 will give us the total angles in the shape. So we go ahead, 180 multiplied by 4, put that in your calculator, or you could just count up by 180. And that gets us 720 degrees. Beautiful. How do you know this shape is not a regular polygon? I kind of gave that away just now on the first question, and the answer is because all the sides and all the angles are not equal. So remember, in a regular polygon, all angles and all sides are always equal. So answer, all sides and angles are not equal. So the sides and the angles are not equal. There we go. So we're going to do another question here on polygons. We're given this shape here, and we're asked to identify the name of the shape. What is the sum of the interior angles? So again, we go ahead and we count all the sides. So I've got 1, 2, 3, 4, 5, 6, 7, 8. I can see here that all the sides and all the angles are the same. Hence, this is a regular octagon because it's 8 sides. So oct means 8. So we go ahead and we write regular octagon. Now we get to the part that asks us to find the sum of the interior angles in the shape. Again, reminder of the formula. It's 180 n minus 2. N is the number of sides, so therefore it's 180, 8 take away 2. So an octagon will have 6 triangles, so it's 180 multiplied by 6. We go ahead and we put that in our calculator. So 180 multiplied by 6, and that gets us to 1080 degrees. Well done. So this is a regular polygon, we're told clearly. Now calculate the size of the interior angles. So because we are asked to find the sum, when you say the size of the interior angle, it means we need one of them. So therefore, we know all the angles add to 1080, and we know there are 8 of them. So it's going to be 1080 degrees divided by 8. Put that in our calculator again. So 108 divided by 8 is equal to 135 degrees. Okay, connected question. Work out the size of the external angle. Now, we know the relationship between an interior and an exterior angle is that they add to 180 degrees. So I'll just help you to visualize that here. So if I extend my line to get an exterior angle, the angle inside of the shape we just found to be 135. So we could just call that one x. Therefore, the exterior angle would be equal to 180 take away the interior angle. So 180 take away 135. So we put that in our calculator or column method. So 180 take away 135 gets us to 45 degrees. So that would be the size of one exterior angle. Just want to take the opportunity here to remind you that regardless of the polygon that you've got, all exterior angles for all polygons will add to 360 degrees. And that's because if you cut the exterior angles off and you put them all together, they will form a circle which is 360 degrees. Now we move on to a question for application. So we're asked to say how many sides does a regular polygon have if its exterior angles are 45 for A and B 30. So I've just given you that formula on the other slide. So we want to find out the number of sides. So number of sides is equal to 360 degrees divided by the exterior angle. So once we divide an exterior angle into 360 degrees, it will now tell us how many sides the polygon has. So the first one for A is 45 for the exterior angle. Therefore, 360 divided by 45 will tell us the number of sides. So we put that in our calculator again. So 360 divided by 45 will get us to 8. So the answer is 8 sides. Okay, now we go ahead, which means you can just also write down it is an octagon, because we know an octagon has 8 sides. We go ahead and we do part B. So for part B, the exterior angle is 30 degrees. So we do the same what we just did, 360, but this time divided by 30. That's an easier one because we could just divide by 10 first, and then 36 divided by 3 gives us 12. So this one has 12 sides. But do you know what the name of a 12-sided shape is? I hope you remembered. It is a dodecagon. So do, and then decagon. So do for 2, decagon for 10, so 12 altogether. Okay, now the next question here says, how many sides does a regular polygon have if its interior angle, so I'm going to underline that, are 156 and 162. Now, I know you'll be tempted to just go ahead and do the same principle that we done in the first one. But if you look here, the difference here, the first one gave us the exterior angle. This one gives us the interior angle. However, we know that an exterior plus an interior angle add to 180 degrees. So therefore, if I know the interior, I can take that away from 180 to get the exterior and then apply the formula we did in the question above. So let's go for the exterior angle. So the exterior for A will be equal to 180 take away 156 degrees. Let me just put that in my calculator quickly. So it's 180 take away 156, and that's equal to 24. So the exterior angle is 24 degrees. So now I know that number of sides is equal to 360 divided by exterior. So I'm going to go ahead and do 360 degrees divided by 24. Put that in my calculator again. So 360 divided by 24. And that gets me to 15. So 15 sides for that one. So part B will follow the same method. So I know my interior, I can get my exterior. It's 180 take away 162. That gives me my exterior. So 180 take away 162. And that's equal to 18. Please note that these could also be your non-calculator questions. So you would just use your column method in the interest of time, and also to make sure for accuracy, just to make sure I give you the correct information as you revise, I'm just using my calculator. Okay, but once you have the principle, you know how to navigate it as well. So subtracting that, we get 18. Now I just need to do 360 divided by 18. And put that in my calculator. I can see here though 18 is half of 36, so clearly that's going to be 2, and then we've got 0, so that's 20. And this one, 20 sides, is called an icosagon. Okay, just to make sure that you know some new words as well. So there we have it. Make sure that you watch this video thoroughly and you refresh yourself on all the formulae that you need to navigate this. Very, very important that you know this, as you will not be given these in your exam. Now we're going to go on to remind ourselves of finding the volume of the shape. Now, what is the name of this shape? I hope you recognized that it is a trapezium. So again, we've talked about finding the volume of prisms, and I hope you can remember on your own now what is the formula. So it's the area of the cross section. So I'm just going to write that again. So the volume, area of cross section, and I'm multiplying that by the length, which is the distance from the front of the shape to the back of the shape. Awesome. So we can see here that if I should slice this uniformly, I will always get a trapezium. Hence, the area of the cross section will be the area of the trapezium. So again, I need to be able to recall the formula for the area of a trapezium. So let's go. So area of trapezium is equal to half A plus B multiplied by the height, where A and B are the parallel sides. So across here, you can call that A, and all the way across here, that's B. And it really doesn't matter what order we put them in once we have added them together. So, and then we multiply by the height, which I've identified. Here is 5, so we put that h in. So we're going to deal with that and then multiply that by the length. So let's go. So it's half of a is 9 plus b is 13. And when I get my answer, I'm just going to multiply that by the height of the trapezium, which is 5. Okay, I'm going to go ahead now, put that in my calculator. If I add 13 and 9, I get 22. And then I need to half that, which is 11. And then multiply that by 5. 11 times 5 gives me 55. And my unit on my diagram is centimeters. So it's going to be centimeters square. Now a thought just came to my mind. Always make it a practice that once you're going to do a question on any linear components involving, which means it's involved length, always make a quick check that all of your lengths are in the same unit. For example, everything needs to be in centimeters. If it's not, then you have to make sure that you convert them to make them the same. So now we found the area of our cross section. We now need to multiply that by our length, which is 7. So we go ahead and we write that the volume is equal to 55 centimeters squared multiplied by my length, which is 7 centimeters. I go ahead and I do 55 times by 7. Put that in my calculator. 55 times by 7, which gives me 385. Now centimeter squared multiplied by centimeter gives me centimeters cubed, and that's why volume is measured in cubic centimeters. So there we have it. We have found the volume of a trapezium face. Is a trapezium multiplied by the length, so it is a prism that has the face of a trapezium. So on we go. Now we're going to practice another one of these, but this time we're told to calculate the volume of a triangular prism. So again, formula remains the same regardless of the fact that this time the cross section is a triangle. So volume is equal to area of my cross section. So area of cross section, and then I multiply that by my length. Okay, so I'm going to go ahead, find the area of my cross section, which is a triangle. So area of the triangle is equal to, I hope you remember the formula, it's your base times your height divided by 2, which we could also say half base times height. So here it's very important not to mix up your measurements. Remember, your height has to be perpendicular to your base, which means together they form a right angle. So if you look here, you can see the right angle. So my base is 4, so it's going to be 4 multiplied by my height, which is 7. And then I need to divide that by 2. So 4 times 7 gives me 28. And then I need to half that. So half of 2 is 1 and half of 8 is 4. So therefore we get 14. So we now need to multiply this by the length, which is 6. So I go ahead and write that my volume then would be equal to 14 centimeters squared multiplied by the length, which is 6 centimeters. I'm just going to go ahead and put that in my calculator. So 14 times by 6, and that gets me to 84 centimeters squared multiplied by centimeters give me centimeters cubed. So there we have it. We have found the volume of a triangular prism. Beautiful. I am absolutely proud of you. So on we go. Now in this question, we're asked to calculate the length of side X and give your answer correct to 1 decimal place. So I'm going to just underline that degree of accuracy. Remember, it's very important to see what the question told you they want the answer to be at the end. Now we look on our diagram here. It's a right angle triangle. Remember, when it's a right angle triangle, there are just 2 possibilities. One is Pythagoras' theorem, or it could be trigonometry part, which is SOHCAHTOA. Now, I'm observing my diagram and I'm checking. Remember, if it's Pythagoras' theorem, it has to be that we're given at least two sides of the triangle. If we're only given an angle and a side, we know we have to use SOHCAHTOA. So I look on my diagram here, I can see I'm given an angle and also a side. So I do not know a second side, therefore I know it's SOHCAHTOA. So go ahead and write it down, SOHCAHTOA. So we know that S is for sine, opposite, hypotenuse, OH. Cos ratio is adjacent divided by the hypotenuse, and the tangent ratio is for the opposite divided by the adjacent side. So remember, my reference point is always my angle. So I go to my diagram and I'm going to stand at 36 degrees. Now, across from 36, opposite to that is the opposite side. But I can see here, I was not given a number. So opposite is out. Now, I know that the opposite, the right angle, is always the hypotenuse. So I'm just going to go ahead and label that H. It means then that the other side marked X has to be the adjacent side. Very good. So I've got A and H. I check my ratios and I can see here that it is the cos ratio that has both A and H. So I know I'm using cosine. So I go ahead and I write my formula out. So cos theta, which is my angle, is equal to the adjacent side divided by the hypotenuse. So step 1, I labeled my diagram. Step 2, I now write my formula out. Now I'm going to substitute in the formula. Chose my ratio to be cos. Now it's substitution time. So from 36, we know we've labeled, so adjacent is X. So we're going to go ahead, cos theta, theta is 36, put that in, equal to the adjacent side, which is X in this question, and my hypotenuse is 12. Now remember, when the variable is in the numerator, I am multiplying. However, to avoid that confusion, I could just put this side over 1, and then I'll see I'm cross multiplying. So 1 times X gives me X. And that's equal to, I now need to do cos 36. Remember, you must put that 36 degrees in bracket. Failure to do so will tell your calculator to multiply cos 36 times 12, which is a different answer from the cos of 36 and that answer multiplied by 12. So now all we need to do is to put this in our calculator. Now, because we are going to be rounding to 1 decimal place, it's useful to first of all write down at least 3 decimal places, and then we need to check to see, are we rounding up or are we rounding down? So I'm just going to put that in my calculator now. So cos 36 multiplied by 12, and to 3 decimal places, that is 9.708. Question asks me to round to 1 decimal place. The first digit after the decimal is a 7. I then need to check on the digit behind. Remember, 5 or more rounds up. Below that, I round down. So I'm not adding anything to 7. So X therefore is 9.7 and the unit is centimeters. Now, another very important thing here to remember, once you're going to do anything on your calculator regarding angles, always check your calculator is in degrees. If it is not in degrees, you're going to get an incorrect answer. How do you know it's in degrees? That tiny little d should be on your calculator. Beautiful. So now we're going to move to another question. This question also has to do with a right angle triangle. However, this time we are finding an unknown angle because we can see X is where the angle is. So we're asked to work out the size of angle X of the angle marked x and give our answer correct to 1 decimal place again. So step 1, we need to identify that we're going to need to use our trig ratios again. So, ca, toa. I'm now going to go and I'm going to label the sides of my triangle. So I'm going to stand at the angle. I can see the side I have labeled 10 is the opposite side, and across facing the right angle is the hypotenuse. Therefore, I've got O and H. I check my ratios to see which one has both O and H, and that is the sine ratio. So I am using sine. I've chosen my ratio. I'm now going to write my formula down. So sine theta is equal to the opposite divided by the hypotenuse. Now in this question, I do not know the angle, so I'm going to replace it with the letter on the diagram, which is x. So sine x is equal to the opposite side, which is 10, divided by the hypotenuse, which is 15. Now remember, when we are finding an unknown angle, we need to use the inverse function. So I'm going to do x equal to the inverse of sine is sine inverse, which we write as sine to the power of -1, and then divided 10 divided by 15, and we put it just like that in our calculator. Remember, we've got to press shift or second function to bring the inverse function up. And I have done a thorough lesson on trigonometry as well, so if you need extra practice, just go to that video on trigonometry there and you'll see me talk about. I've also showed the calculator just in case you're struggling with that. I've shown you how to get the function up as well. So let's put this in our calculator now and get the final answer. So sine inverse and then 10 divided by 15. And we're rounding to 1 decimal place, so x then is equal to 41.8 degrees. I hope that you're really working along, getting your paper, writing these things down, because the more that you write, the more you will remember what you have done as well, and that will stay permanent with you as you go into your exam. Okay, so we're moving along to our next question. These two right angle triangles are similar. So now we get in the concept of similarity. Very much, a lot of questions are usually done on similarity in your curriculum. So I know you've already done quite a few of these, but let's see an application question here. So we're given two triangles. We're told they're similar. So we know straight away that if two shapes are similar, then one will be a scale factor of the other. It will be an enlargement of the other. Now we're asked to write down the value of sine x. Let's underline that and give your answer as a fraction. Clearly, this must be a calculator paper, a non-calculator paper, because now you will be just writing down the length of the side and you have to now simplify by finding your common factors. So sine x, if they're similar, then their sine, regardless of the triangle you use, the sine of the angles will still be the same on both of the diagrams. So let's go. So from x here, I know sine is the opposite divided by the hypotenuse. We can just write that down. So we're looking for the opposite divided by the hypotenuse. So sine x is equal to the opposite here is 6 and the hypotenuse is 10. So it's equal to 6/10. Okay, we have to use that triangle because it's the only one where we already know two sides. So now we need to simplify this. So we can half both numbers. So half of 6 is 3 and half of 10 is 5. So therefore, sine x is equal to 3/5. We tick that off. We're finished with part A. Now part B asks us to work out the value of y. Now because the two shapes are similar, we can go ahead and find the linear scale factor that links them. We can see here, I know two matching sides. I've got 10 meters which also links to 25. So I can find my linear scale factor if I do 25 divided by 10, and that gets me to 2.5. Now, in order to find y, I need to make a link with the matching side for y on the smaller triangle, which is 6. And I know y is going to be larger because it's on the larger triangle. So therefore, y is equal to my scale factor multiplied by 6, and 2.5 times 6. If this is a non-calculator paper, this simply means I've got 2 lots of 6, which is 12, and also a half of 6, which is 3. Add them together, I get 15. If it's a calculator paper, I could just go ahead straight away and put 2.5 times 6 in my calculator. Beautiful. Now, I could also have done it another way, because I was asked to find sine x in the beginning. So therefore, I could also go ahead and use that as well. So I know that sine x is 3/5. So 3/5 then is equal to y, matching side, opposite, hypotenuse. So that would be y divided by 25. If I match the sine of the first triangle with the sine of the second triangle. So it will be opposite, which is y, over hypotenuse, and then I could cross multiply. So 5 times y is 5y, and that's equal to 25 times 3, which is 75. I then need to just divide both sides by 5. So y then would be equal to 7 divided by 5 is 1, and then I bring 2 for my remainder. 25 divided by 5 is 5. So therefore, whether using the sign we were given, or if you got stuck using that method, you could have just used your knowledge of your scale factors and then just multiply my scale factor by the side I know, and then I could have also, so any method that you're comfortable with, make sure you choose that one. Unless the question say hence. Very, very important thought, because if you're given part A and then part B say hence find the value of y, you must use this method, because that's a clear indication they want you to use the value or the answer you got in part A to solve the part in B. So if you use the scale factor method after the word hence, you wouldn't have followed through the question. Okay, so moving along. Now we go to make D the subject of this formula. So rearranging formula, which lots of students find difficult. However, that's not going to be you, because we're going to do it in a clear, logical way. Now, when we are navigating rearranging formula, it is very important, first of all, to note the operations we are given in the question, and also writing down the inverse of those operations. Now, in the question here, we are asked to make D the subject. Now, to make this D the subject, that means we need D to be by itself on one side of our equation. So at the moment, E is our current subject because it stands alone on one side. So what I want to do is to get D on its own. So I'm going to write down the operation I have in the question, and also what I need to do as a result of what I have. So at the moment, I have a plus 5. I'm going to need to do the inverse of that, which is minus 5. So I need to do that to both sides of my equation. So I need to add 5 and I need to subtract 5, and I need to subtract 5 on the other side as well. So I'm going to tidy up the side here. So it's E minus 5. 5 take away from 5, that's equal to 0. So we now have D on its own. It's really a good practice to put D on the left-hand side. So I'm just going to rewrite this, that D then is equal to e minus 5, and I check that I've done the inverse. So I had a plus 5. To remove that, it's going to be the inverse, which is minus 5 on both sides. So e minus 5 will be equal to d. So we take that off, we go to our next question. So here I've got rearrange t equal w divided by 2 to make w the subject. Again, I think about what I have in the question as my operation and also what I need to do to remove what I've got. So I'm going to write again my have and my do. So currently in the question, I have a division by 2. Therefore, I need to multiply by 2, inverse of my operation. Remember, I do that to both sides. So I'm just going to rewrite it here. T equal to w divided by 2. I need to times t by 2 and also this side by 2. So t times by 2 is 2t. And then I would have cancelled this bit out. 2 divided into itself goes once, leaving us just with w. So now we've made w the subject of the operation. Therefore, I'm going to rewrite it on the left-hand side. So w is equal to 2t, and there we've got it. Awesome. So now we go on to another question, but this time we need to do more than one steps. So I'm going to observe. We're asked here to express v in terms of t. That's just another way of saying make v the subject. Now, even if you didn't know that, clearly in the question, t is already the subject and there is only one other variable. So therefore, I can reason they're asking me to make v the subject. So let's go ahead. We're going to write down what I have and what I need to do. So have and do. Currently, I am doing an addition by 1. So plus 1. We're going to need to minus 1. Also, I'm dividing by 4. So now I'm going to need to multiply by 4. I'm going to take care of my constant first, which is plus 1, so that now I will be able to have access to v. So we're going to rewrite the question. T equal to v divided by 4 plus 1. I need to go ahead and subtract 1 from both sides. So minus 1, minus 1. Tidy up this side, I get t minus 1 equal to v divided by 4, since plus 1 and a minus 1 cancels to 0. So I'm just going to tick this off that I've done my inverse of plus 1. I now need to do the inverse of division by 4, which is multiplication. Now, this is very, very important here. I'm going to be multiplying by 4. However, I need to put that 4 on the outside of a bracket. Now I've got an expression. I have to remember I'm going to multiply both t and minus 1 by 4. Very important here. So let's go ahead. This is supposed to be multiplied by 4, the other side by 4 as well. But to express the left-hand side, we're going to do 4 bracket t minus 1. And that's going to be equal to, these two 4s will divide each other out, leaving 1. So now I've got v. So the answer then is v equal to 4 bracket t minus 1, close my bracket. There is no need at this point to expand the bracket, so that's okay to leave it just as it is. Okay, if you were to expand the bracket, you would have gotten 4t. So I'm just going to put it here. If you were to expand, so if you expand, it's okay to expand though. It will be 4 times t, which is 4t, and 4 times minus 1 is minus 4. So that's also another representation that you could have had as well. So we're going on to the last question on this slide. Make w the subject. So we've got a equal to w minus 2 divided by 6. I'm going to write what I have and what I need to do. I have a division by 6. so I'm going to do a multiplication by 6. I also have a minus 2, so I'm going to need to do an addition of 2. I'm going to rewrite this, so A is equal to W minus 2 divided by 6. We're going to take care of the 6 first. I'm going to times both sides by 6. So 6 times A gives me 6A, and that's equal to, these two 6 will divide each other out, leaving 1, so that's W minus 2. I'm going to now tick that off to say I've done the one for multiplication by 6. I now need to do add 2 to both sides. So then I get 6A add 2 is equal to 2, and minus 2 cancels out to 0, so that's W. So I can then go ahead and write that W is equal to 6A add 2. Beautiful. So I hope that you are still in the rhythm and that momentum is going, and you're excited to see what the other question that's coming after this one. Amazing. So let's carry on. Now here we are asked to solve for x and y. Clearly we can see we've got a pair of simultaneous equations. So we are going to first of all just talk ourselves through. We've got 5x plus 3y equal 27 and x plus 3y equal 15. Now remember, when we are solving our simultaneous equation, we can do so by the method of elimination, which is the most appropriate method at year 9. When you get to year 10, then you'll start looking at substitution method and so on. So remember, first of all, I need to check that at least my x or my y terms balance. And that means I need to have one pair, either in x or y, that are exactly the same coefficient. So if I look here, let's call this equation 1 and this one equation 2. So I can see here that both of the y's are positive 3, which means that the y terms are balanced. When we have both of the terms being positive, in order to eliminate it, we need to subtract. So I'm going to go ahead and I'm going to subtract equation 2 from equation 1. So let's go ahead. I'm just going to put 5x plus 3y equal 27. I always like to write my question out again so that I do not confuse my working with the question I was originally given. Very good practice. So I know I have to subtract if I'm going to eliminate the y term. So let's go. 5x take away x gives me 4x, and 3y take away 3y cancels out to 0, and that's equal to 27 take away 15, so 7 take away 5, that's 2, and 2 take away 1, that's 1. So now to get x, I need to divide by the coefficient, which is 4. So x then is equal to 12 divided by 4 is 3. Now I need to substitute that in any one of the equations, whether 1 or 2. I can see it's easier to substitute in the second one. So let's go. So x plus 3y equal to 15. I know x is 3, so let's go ahead and put 3 here, plus 3y equal 15. Now we've just done before rearranging. So we're rearranging to make y the subject. So we need to subtract 3 first of all. And then we've got 3y equal to 15 take away 3, which is 12. I now need to divide by 3. So therefore, y is equal to 4. So my answer is x is 3 when y is 4. And I can quickly check to see if that's true by just simply substituting both of them into the equations and see if I get the answer on the right. So if x is 3, then for this equation 2, then it's going to be 3 plus 2 times y, y is 4. Sorry, 3 times y is 4, 3 times 4 is 12. I can see 3 plus 12 is 15. So I know I'm correct. And also, if you have time, you can just check that they also work in the first one. Now we go to solve the next equation. So I check again, I'm trying to eliminate, and I can see here 8x plus 6y equal 130 and 5x minus 6y equal to 13. So I'm seeing here where my coefficients of the y's are, one is positive and one is negative, but the numbers are both 6. So that means I can eliminate the y term. However, because one is a positive and one is a negative, I have to add the equations to remove the y term. So it's 8x plus 6y equal to 130, and then 5x minus 6, right, it's probably 6y equal to 13. So I now need to add them. So I'm putting a big plus sign for you to see that. So I need to do 8 plus 5, which is 13, coefficient, and then the variable is x. A positive and a negative of the same magnitude cancels to 0. So this will cancel out, leaving me with 13 add to 130, which is 143. I now need to divide by 13 to make x the subject. So x then is equal to, I'm just going to quickly put that bit in my calculator. So 143 divided by 13, that gets me 11. Now I need to substitute this in either equation 1 or equation 2, it doesn't really matter. So I'm just going to go ahead and substitute it in the first one, and I would advise as a student you do that too, because sometimes students get confused with the negative terms. So let's go. So it's going to be 8x plus 6y equal 130. And then I need to substitute x for 11. So 8 times by 11 plus 6y equal to 130. Therefore, I get 88 from this bracket pair. So 8 times 11 is 88 plus 6y equal to 130. Now I need to subtract 88 from both sides. So I've got left 6y equal to 130, take away 88. We can just put that in our calculator, and that gets us to 42. We then need to divide by 6, and so therefore 42 divided by 6 gives us 7. So therefore x is equal to 11 we got in the first place, and then y is equal to 7. And again, we can also just check if that is true by substituting them into 1. So if I substitute in the first one, 8 times 11 is 88, plus 6 times 7 is 42. Add them together, I get 130. Brilliant. So we're going to move on to our next question. So in this question, we're asked to complete the values for y equal 2x minus 2. So we're given the table and we have given some of the values as well. So all we need to do is to just observe the rule of the graph and substitute the x coordinates so we can produce the corresponding y coordinates as well. So for the first one here, we have been given minus 2. So that means in the equation, x is going to be substituted for minus 2. So I'll just put that here. So y equal to 2, bracket, what I'm substituting, always a good practice to put that in the bracket as well. So I've got minus 2 and then minus 2. So we go ahead, we expand. So 2 times by minus 2 is minus 4. And then we've got minus 2. So together, minus 2 and minus 4 is minus 6. Remember, I owe 4, I borrow 2 more, I will owe 6 altogether. I put that on my table, which means that on the graph, I'm going to be having minus 2, minus 6, which I will now plot as a coordinate. I go ahead and I go to 0. So y equal to 2 and x this time is 0. And then minus 2. So I've got 2 times 0 is 0 minus 2, which will also give us minus 2. We put that in our table. Now, when we're doing this table, we can also look for patterns. We can see here we've got -6 and -4, then -2. So clearly we are going to have 0 here. So once you pick the pattern up, then you don't have to always just substitute in. Now we can see we're going up by 2. So therefore the other missing value will be 4. So what we need to do now is just to plot the points on the graph for part B. It says on the grid, draw the graph of y equal 2x minus 2. Always pay attention to the scale that you are given. Don't just go ahead and plot. We can see here that on the x-axis, let's label that, on the x-axis we're going up by in terms of 1 unit, but on the y-axis we're going up in 2s. So let's go ahead, just label 0 here since they didn't give that on the graph. So the first coordinate we're going to plot is -2 and -6. Remember, we go x first, followed by y. So -2 on x is here, and we need to go to -6, which is all the way to the bottom. We make a cross. Then we need to do -1 and -4, which is here. We then go ahead, we need to do 0 and -2. So we go for x at 0, right at the origin, and then we go to -2. We know we're plotting a linear graph, which means we must get a straight line. If I'm plotting and I see the coordinates not oriented towards a straight line, then I know something in my coordinates is wrong. Next one is 1 to 0, means I go on x, but I do not move for y. Then I've got 2, 2, and then followed by 3 to 4, which is here. Once I've finished doing that, I just need to simply take my ruler, connect the points, use my pencil, draw that line. So I've pre-drawn the line in, so that's what it should look like. And also, a good practice is to put the name of the graph on the graph as well. So y equal 2x minus 2. Now I've just put some extension questions, part C and D, just to remind you of how to write down your gradient and your y-intercept from the equation of a straight line. So we know part C asks us to write down the gradient. I know that the formula for the equation of a straight line is always in the form y equal mx plus c. So m is my gradient and c is my y-intercept. So all I need to do is to just check in the equation what is the coefficient of x, because m is the coefficient here. So therefore the coefficient of x will be my gradient. Therefore m is equal to 2. Great. The y-intercept is my constant, which is where the line will cross the y-axis. Therefore, I could also have identified that on my graph. I can see right here at -2 is where my graph crosses the y-axis. But I could also have written it down from my equation as well. Constant here is -2. So c is equal to -2 for my y-intercept. Beautiful. Now we're going to move on to another graph question. So here we are asked to find the equation of line L in part 1, and in part 2 find the equation of line M. Then in part 3 to write down the coordinate of the point where line L and M intersect. So when we're dealing with linear graph, the first thing that we need to do is to write down the general form of a line graph, which is y equal to mx plus c. We know m is our gradient, and we know that c is our y-intercept, and again, that is where the line crosses the y-axis. So in order to write the equation of line L, we need the gradient m and also the c, which is the y-intercept. Once we've got that, we just need to put it all together in the equation of a line. So another very important part before we start finding the gradient and writing down the y-intercept is to look at the orientation of the line. Remember, the line L here is oriented from the right to the left. Now that means it will have a positive gradient, and I'll just put M for the gradient, which means then that the line M is going to have a negative gradient. It's very important to note that. Now that we established that, let's go and find the gradient of the first one, which is line L. So I'm just going to say line L, and we're trying to find the gradient, which is M. Now from the graph, remember, we can find the gradient by doing y over x, which is also set rise over run, which students always like to use that just to remember that we do y and then run, which is x. So to do this from the graph, we need to draw a perfect right angle triangle, and then we're going to do y divided by x in terms of the values that we get from the triangle. Now importantly, we must pay attention to the scale of the graph. That will influence the numbers that we're using. So if I choose this point here dead on the line, and also this one dead at the intersection here, I can see that this triangle will have perfect squares. So the graph is going up in scale of 1 on the x-axis and also the y, so we can count the squares. If that's not the case, we need to count the units instead of the squares. So counting on the y, I have 1 square, 2 squares, so the y here is 2, and going across, I only have 1, so I'm dividing 2 by 1, which is 2. That means the gradient M is equal to 2. I can just look on the graph now and see where the line L crosses the y-axis, and I can see it crosses it at positive 3. So C is equal to 3. Now I've got it all, I just need to write it in an equation. So y is equal to, my gradient is 2, so that's going to be 2x, and my y-intercept is 3. So the equation of the line then is y equal 2x add 3. Beautiful. Now we're going to go on to the second question, which asks us to do same, find the equation of the line M. Just a reminder, M will have a negative gradient. So we need to find what is the gradient. So line M. Going to get the gradient, which is M. So again, I'm going to make a perfect right angle triangle. So I'm going to use the point here and also the one here, and then I'm going to write y over x. So that will be equal to y divided by x. I can see if I'm going down here, it's going to be minus 1, and I'm going one movement from here to the right, so that's positive. So the gradient of this line then is negative 1, because I'm doing minus 1 divided by positive 1. So now I've got my gradient. I'm now going to do the y-intercept. But for this one, I can see that the line crosses the y-axis at 0. And we know there will not be a visible y-intercept. Therefore, we can go straight ahead and write that y is equal to, my gradient was minus 1, so I could write minus 1x. But we know we don't have to do that. We can just go ahead and write y equal to minus x, and that would be the equation of that line. And we can check to see when we've got 1 air for x, then y is minus 1. And then when we've got 2 for x, then y is the opposite of that, which is negative 2. On the other side, when x is minus 1, then y is going to be the opposite of that, which is positive 1. Clearly. Now we need to answer question number 3. Question number 3 asks us to write down the coordinates where the two lines intersect. Now, a beautiful opportunity here to tell you that this is what you're looking for when you're asked to solve a pair of simultaneous equations. You're trying to find out where two straight lines intersect, and this is what it looks like on the graph. So we can see here both of the lines cross each other. I'm just going to circle it to make it visible. They cross each other at that point where x is -1. So let's put our bracket, -1 for x and +1 for y. So they intersect at -1, 1. Beautiful. Now we're going to move on to our next question, which asks us to simplify the following ratios. So we know when we're simplifying ratios, we need to find common factors. Now, if you're not able to find the highest common factor, you can start with the factor that you know and then keep simplifying until you cannot simplify any further. So I'm just going to go ahead and I'm going to write 4, 10. I can see here that 2 is a factor, so I need to divide both sides by 2. So I've got 4 divided by 2 is 2 and 10 divided by 2 is 5. So simplified form is 2 to 5. We go to do part B, where we're asked to simplify 9 to 15. So we need to divide by 3 this time. So divide by 3 on both sides. So 3 into 9 goes 3 times and into 15 goes 5. So that one simplifies to 3 to 5. Okay, now we go to our next question. So frozen characters Elsa, Anna and Olaf have a snowball fight. They throw snowballs in the ratio 3 to 5 to 7. Anna throws 45 snowballs. How many snowballs do Elsa and Olaf throw? So we're going to write the numbers out of the words. So let's write the characters here. We've got Elsa, so I'll just put E for Elsa, A for Anna, and O for Olaf. So I know that the ratio between them or among them is 3 to 5 to 7. Awesome. So I'm just going to tick that off. I have written that out. Remember, you've got to put the ratios in terms of the order in which the names come in the question. So we got Elsa first, she's 3, Anna is 5, and Olaf is 7. Now Anna throws 45. So we're going to put the 45 under her ratio. And we're asked to find how much does Elsa and Olaf throw. So I have to use Anna's amount to find out one part of the ratio. So I can see 45 represents 5 parts. So if I do 45 divided by 5, I will find one part of the ratio. So 45 divided by 5 is 9. So that means one part represents 9. So we can now go ahead and find out Elsa's by doing 3 parts times by 9. So let's go. So Elsa would then be 3 times by 9, which gives us 27. So that's 27 snowballs. And then Olaf. O for Olaf, he's got 7 ratio parts. I'm going to do 7 times by 9. And 7 times 9 gives me 63. So Olaf is 63 snowballs. And there we go. So we just need to find a breakthrough in the question, which we did. Well done. Okay, so now we're going to go on to looking at our simple interest, compound interest. All right, so let's go. So James invests £200 in 1 year in a bank account. The account pays simple interest at a rate of 3% per year. So I'm just going to go ahead and underline 200 and 3%. Work out the total amount. So careful here, the total amount, not just the interest, but the total amount of money in the account at the end of the year. So we need to write down our formula for a simple interest. Now there are multiple ways to do this, but I'm just going to go straight ahead to where I find the interest first, and then I'm going to add it on to the original. So interest is equal to my principal multiplied by my rate multiplied by my time, and my principal is what I start with. So I'm just going to substitute these values in and then find the interest. After I've done that, I now need to add the principal with the interest, and that will be the total I have at the end in my account. So the principal is 200. The rate is 3%, which we can write as 0.03, multiplied by the time, which in this question is 1 year, so no effect there on our multiplication. So if I do, I'm just going to put that in my calculator quickly. If I do 200 times by 0.03 times by 1, that gets me 6. So that's £6. So the total then has to be 200 plus the £6, which gets me £206 at the end of the year. Next question. Sammy invested £400 for 2 years at 5% per year simple interest. Work out the total interest. So this question is different because what we want is the interest. So therefore, I'm just going to go ahead and do interest is equal to my principal multiplied by my rate multiplied by my time. So principal in the question is 400. So 400 times by my rate, 5%, which I can write as 0.05. This time, my time is 2 years. So I substitute that in. I'm going to put that all in my calculator. So I need to do 400 times by 0.05 multiplied by 2. And that gets me to £40. So that's my answer, because specifically I was asked to work out the total interest. Beautiful. Moving along. Now we go to Fiona. Fiona leaves £1,600 in the bank for 4 years. So principal, let's underline. Then it's for 4 years, that's our time. It earns compound interest. So this is different from the simple interest at 4% each year. Calculate the total amount Fiona has in the bank at the end of 4 years. So we know our time. Very important here is to know the formula for compound interest. So the formula for compound interest is that the amount at the end is going to be equal to the principal multiplied by 1, which is the 100% is what we start with, plus the interest rate here that we are told that it's going up by, to the power of n, where n is the number of years of the investment. So I've put here the words, A is our final amount including our principal, that's what we're after. P is for the principal amount, what we start with. I is for the interest rate per year. And n is the number of years. So we're going to just substitute the values from the question into the formula, put that in our calculator. So here we go. So A then is equal to our principal, which is 1,600, bracket means multiplication. So it's going to be 1 plus the interest rate. So 1 plus our interest rate is 4%, which we can write as 0.04, and that's being raised to the power of the years, which is 4 years. Okay, now we could just go ahead and add 1 plus 0.4, which is 1.04. So 1,600 multiplied by 1.04 raised to the power of 4. We put that in our calculator and then we will have found our total. So 1,600 multiplied by 1.04 and the power is 4. So the answer is, and remember this is money, so we've got to end in 2 decimal places. So it's 1,871.77 and the unit is pounds. Beautiful. Awesome. So let's go. So we're going to go to look at our direct proportion. So y is directly proportional to the square of x. Note here, it's the square of x. So direct proportion to the square of x. So let's write that down. Y is directly proportional to x squared. When y is equal to 24, so we can visualize it a little better, y equal 24, x is equal to 2, find the value of y when x is equal to 4. We know once we're talking about direct proportion, we are talking about a constant scale factor multiplied by one variable will produce the other variable. Therefore, my first step is to find my constant. So therefore, I know if it's direct proportion, it's going to now be y equal to k, which is my constant, multiplied by x squared. So now what I need to do is to find k by substituting the values I'm given for y and x. So let's go. We're told that when y is 24, then x is 2. So then 24 is equal to k, my constant, multiplied by 2, which is x squared. So 2 squared is 4. 4 times k is 4k. So 24 is equal to 4k, and I can find k by dividing by the coefficient here, which is 4. So k then will be equal to 24 divided by 4 is 6. So therefore, the equation that links them is that y will always be equal to 6x squared because k is 6. Now that I've written my formula that links them, I can find any value they've asked me to find. So I was asked to find the value of y when x is equal to 4. So therefore, y is equal to 6 and x is 4. So remember, we're squaring that. So it's going to be 4 squared. So 4 squared is equal to 16. So we're in essence multiplying 6 by 16. Okay, this is easy to do on a calculator or non-calculator. So 6 times by 16 gives us 96. So the value of y will be 96. Beautiful. I am absolutely proud of you. You have completed an entire walkthrough for your exam. Awesome. Now it's at this point I will say you should go over the video as many times as it takes so that you are confident with any question from any strand of the curriculum. And if you haven't yet shared, like the video, hit the notification bell, make sure that you do that. And also remember, additional questions are also on TikTok where you can go and engage as well. You are brilliant and becoming brilliant by numbers. Thank you so much for watching.